So we try to cover a bit. Then next week we have more time for your assignment. Okay, your test 2 will be CL3, CL4, project scheduling and cost implication. Then CL4 will be approach used for product development. It is in chapter 7 or chapter 8. Okay. So your test 2 will be in week 13. Week 13. Okay. So now we go into quality management. Then we'll look at some of the tools. Some of the tools. Okay. So what is quality? So this one you can read. Quality is level of excellence. So quality is based on who you are selling to, your products. Product here can be real products. It can be services too. Product design here, it can be two types of products. One is physical products and the one is services. So the one that you see on the screen here is based on customer and market, the target market. So the first one is fitness for use, the one Mercedes Benz on the top. Another one is quality of design, when they focus on the design, like the Mazda, all these things. So one is focused on the design quality and one is on the services of performance. Right. Quality management, or all the definition, this one you read. We have all the management terms and all this. So this one you go and read. What else? Okay. Now quality from the producer perspective, just now from the customer perspective. Customer, you have performance and design. From the producer perspective is quality of conformance. So quality of conformance is more on the value. For example, the tires manufacturer, they make sure that the products are manufactured according to the specification, right? So, for example, tires, right? So tires, if new tires do not conform to the specification, they will wobble. So this one is make sure that the product, this from the perspective that the tires meet certain quality. For example, hotel rooms. Hotel rooms, if the hotel room is not clean during the check-in process, hotel will not functional accordingly. So they become a faulty. So this one is quality of conformance. It depends on industry to industry. So producer perspective is on the conformance, right? For example, education, how do you elaborate on the quality of conformance? Is based on the learning outcome of the student. Okay. Right. For example, this module, how we make sure that there's a quality of conformance for this module. You should able to understand what is project manager roles, what is the organization chart, types of organization chart, what is the design process. Okay. Okay, so this slide tell you the perspective of quality. So there are two perspectives if you refer to this meaning of quality. You have left hand side, right hand side. You are the producer, you look at the left hand side. If you are the consumer, then you look at the consumer side. Okay, producer, you look at conformance and you focus on the cost. If you are the consumer perspective, then you look at the design, quality, and the prices, right? Then you combine these two, you get for fitness for consumer use, right? Okay, so the quality can be two perspectives. One is for the production process, one is for the marketing process. One side you want to get customers, one side you need to consider whether you can manufacture it or not. okay, manufacturing process, and how you sell it, marketing and the production. You combine, you give you the fitness for consumer use. Okay. This on the quality lah. Okay, then as you read. Okay, so these are the few individuals that give you some theory about qualities. This one you read lah. So they are quality gurus, means 1, 2, 3, 4, 5, 6, 7, 8, maybe up to 9. This one you read like what is their contribution. It's like history book lah. You just go and read. Okay. So among all these gurus, Edwards, this one, Edwards is the more prominent researcher or in this area, expert. So go and read what is Deming say about qualities, and so on. This one you read. Okay, Deming's overall philosophy is this one. This guy, Edward Deming. This guy, he have a few for philosophy. So this one also can ask you in the test or final exam. There are 14 points for the philosophy. Of course, we won't test you to ask you to give all 14 points. So maybe it can ask you up to 6 points or 7 points. That's right. Right. So you need to remember 7 out of 14 from here. So this one you read lah. So based on Deming, philosophy of achieving improvement. So it's summarized in all this table. So this one you read lah. There are 14 philosophies. So let's mean he say that it must in your quality policy must be a purpose. Then you adopt preventing poor quality products. Eliminate the need of inspection. Means the first product or first up in your production, once you made it in the phase 1, phase 2, phase 3, is perfect already. You reduce, eliminate for inspection. Right? Means you use a good tools and good control. You select a few vendors that able to commit good qualities. Mean you select a good vendors. When you have a good vendors, you eliminate the needs of inspection. Then this one improve process. Then you give trainings. You give trainings so that your workers, when they are educated, they're able to reduce the problems in the production. Okay. So then leadership, improve leadership so that they manage to manage the staff. Then this one is the fear, eliminating the fear of asking question. Right. So because why? Because the front lines operator, they are the first one who see the problems. So if your staff afraid to raise the problems, then the problem will be there. Then eliminate barriers between departments. This one is more on the teamwork. Then eliminate slogan, numerical targets that urge. So this one is that you need to show your staff how to do it. Right? Not just give them a number to achieve, but show them how to do it. Demonstrate how to do it, or you give them a sample how to do it. Then this one is on the cost without regarding for this one, eliminate. This one you look at the cost. You must meet the process or the quality, design quality must meet the cost that you fix. This one is that you focus on the self-esteem of your workers. Means that you give award, you give reward every time a staff improve something, you announce it or you make it obvious or make it to the company or the staff that actually so and so do improvement and so on. Then this one is organization on the training programs. This one commitment from the management. Okay, you need management to make changes. So these are the 14 points from the DAMINS. So that means it gives you the 4 stage of process for continuing quality improvement. So that means have this simplified features. It's called process for continuous quality improvement. So this is a 4 process. Okay. Again, this one you can draw. Once you can draw, it might be come out in your assessment. Okay. So 4 process: plan, do, check, and act. Okay. Plan, do, check, and act. Plan means you do all the plannings, identify your goal and this. Do, you measure, you plan, you do, measure improvement. Then you check whether the plan work or not. Then you act. You make it a cycle so that you continue to implement the plan. Okay. So these are the tools that you can use. We won't go deep into all these tools, but at least you know what are the tools that for quality control. Okay. So I think some of these tools you already seen in the other module, EDP or other module. But this is just introduce you what are the tools for quality control. One is process flowchart that you see on the screen here. All right, this one you read. So process flowchart. Cause and defect diagram or fishbone diagram. Right? Fishbone diagram means you identify what are the cause of the problems, then you identify the cost of the qualities. So means you put, there's a steps of establishing this fishbone process or cause and effect diagram. What I need to highlight here is the arrow. The arrow in the cause and effect diagram is pointing towards the problems. And then the outside one is the department or the effect that might be give you the trouble. Okay, measurement, human, machine, and so on. The factor. Then you write the cause over here along the arrow here. Okay, checklist is the one that is normally done in the industry, especially when they want to deliver the products, right? Fishbone, this one you read, Fishbone or Ishikawa diagram. This one introduced Japanese. Fishbone. So this is example of fishbone. Right. So this is example of a hospital case where they want to improve the bed turnaround time because they not enough bed for the hospital. So they come up with this fishbone analysis or cause and effect analysis. So they have measurement, personnel, issues, machine, cost method, material and environment. So for example, measurement, they measure by date, weeks, and RN emission. This is the patient when they come in, how you emission them. This is a bit turnaround statistics and so on. Personal, phone, beepers. Environment is a volume, supply, equipment, material, laundry process, wheelchairs, other methods like shift, communication, and room cleaning and so on. So they try to find out what actually causing the bed not enough. Okay. So they at the end they just summarize the issue is because of the bed tracking system BTS. Indicate that the registered nurse RN who admit the patient assign them to a room. So BTS is a system in the hospital. Right, this one you read. So this is how they find problems. But nowadays in this 21st century, all these are registered in the sensor. So you can just open your tablets and then the software will tell you the prompt you the red color. Then you just click there and then see what happens. Right? Okay. So these are the statistics. They record the bait and all this. So you read lah. Check sheet means item 1, 2, 3. You check whether there is a have you completed and all this. Checklist. Pareto analysis. This one is a diagram. You plot graph. What is item 1, item 2, then y-axis, x-axis. Histogram. Histogram is a graph that give you frequency versus the parameter. Okay. This one you read. Pareto analysis. So you change the data into Pareto. So for example, staff communication, this still we still using the hospital case to transfer the data. So you have the causes here, number of defect, you register how many, then total defect is 130, then you do calculation. If 83 out of 130 is 64%, 17 out of 130 is 30%. You calculate percentage, you plot it into Pareto chart. Y-axis is the percentage, x-axis is your cost. You put into this graph. Then it's a presentation or okay, staff communication is the main problem, for example. Scatter diagram, this one you've seen a lot in the Excel sheet, Excel software. Right? Most of the time when you do your FYP, you will see this kind of chart, or in your experiment, lab experiment, you will see this kind of scatter diagram. Then you ask the software to give you train graph and equation. Okay, so later we look at we'll focus on statistic process control chart. Right? Our objective today is to teach you how to calculate this one, ULC and LLC. What is ULC? Is because it's on the top. So ULC stand for upper limit, upper control limit. So this is the mean. The one at the lower is lower control limit, right? Low control limit or lower control limit. This is upper control limit. Okay. So later we will have one exercise doing this one, and this also I might come out this one in your test too lah. Okay. So scatter diagram, this one you read lah. So TQM, what is TQM? So if you went through the industrial training before, so TQM is a very old quality tools used in lots of industry, right? So TQM is a total quality management, and you see lah, there's a few cycle here lah. Consumer, continuous improvement. So continuous improvement here, I want to stress, continuous improvement here, there might be a question ask you, what is their main philosophy on a continuous improvement? There are 14 points. Remember, at least 7 out of 14. So continuous improvement, then quality improvement. Quality improvement. That means quality improvement, not this one. Okay. Accurate evaluation and so on. TQM, total quality management. QMS is quality management system. So these two terms is quite popular in the industry, especially when they talk about quality. TQM or QMS. Okay, basic principle of TQM. So again, we adopt from the Deming 14 points of philosophy. There are 14 points of philosophy. Then we adopt into TQM. So these are the 14 points. You read lah. So quality, manage, consumer, leadership, blah, blah, blah. This one you read. Okay, quality cycle. This one you also read from the slide here. There is a cycle, so 1, 2, 3, 4, 5, 6, 6 item inside the quality cycle. So the first one is about member. Then you go into trainings, go into identification, problem identification. Once you identify, you need to do analysis. After analysis, you need to give solution. Then you do presentation for monitoring. Then you go back to the organization member. Okay. So for your FYP, you focus on here lah. You identify your problem, then you do analysis, then you give solution, then you present your report. Okay, all this you read. Okay, Six Sigma is very popular certification program out there. Six Sigma, you have a few belt, white belt to black belt, right? So what actually is Six Sigma? Six Sigma is developed by Motorola. So very high chances when you go to interview later on for your first job, they might test you, do you know what is Six Sigma and so on. So Six Sigma is developed by Motorola. So yeah, Motorola is a very good company. So if can, you try to apply for Motorola if you want, right? So what is Six Sigma used for? They measure how much a process deviate from the perfection. You set one target, then you see like how many defect or how you control the process. Okay, we look into this one. So Six Sigma, you increase the performance through decrease in the process variation lead to zero reduction or zero defect. Zero defect means out of 100% every time, maybe just one defect out of 1,000 or maybe millions. Okay. Okay, so there are few methods here. So Kaizen, if you work in a Japanese company, they usually will adopt Kaizen. Kaizen is a continuous improvement, so there is a loss of philosophy inside. But still, okay, it's still inside the Deming PDC cycle. Deming PDC means plan, do, study, or this one is what? An action, check action. Okay, so Six Sigma actually is in the textbook. It means it will be like a training of karate, taekwondo. So process is over here. So process you from the left to right. Then you have you define, you measure, you improve, then you control. So you process, you define the process, then you measure the process, you analyze the process, then you check, you control the process. Okay. Okay. Now, the word Six Sigma itself is a statistics word that you learn in the previous chapter where you do hypothesis, like how many percent on the left or right will give you whether it's a go or no go decision. So you have Six Sigma. So you have this is a normal statistic distribution. Okay, so let's say this is your target mu. So you have the first sigma. Again, sigma is a positive negative side. So on the left and right, so you have positive 1 sigma, 2 sigma, 3 sigma, 4, 6 sigma. So you have this is 1 sigma, this is 2 sigma. Right, 2 sigma have left negative and positive region. So this is a total 2 sigma region, and then 3 sigma, 3 sigma, 4, 6, right? 5, 6. 6 is until here. 6 is until here. Okay, so this Six Sigma certification system, you have white to black belt, right? So it's from the workers until leader. This one you read. So you have white, yellow, green, and belt. Okay, this one also you read. Okay, Six Sigma process have 5: define, measure, analyze, improve, and control. So all this you read. You read. So define, you have all these things. Process or measure, you have how you measure. You have all these systems, right? Measure, you have the. Okay, then analyze, you use the cause and effect diagram, fishbone diagram, phi y, FMEA, Pareto, scatter plot, hypothesis, a design or experiment. This one. You learn analyze a lot in the engineering program. Right? You use a lot of tools here. Then improve, you use FMEA. Pokayoki, have you heard about this word? What is Pokayoki? Give an example of Pokayoki. You heard, but you don't know what is it. Which one is you? You heard before, right? Okay. What is Pokayoki? Pokayoki is a go no go method developed by Japanese. Go no go means what? Eh, you know nowadays when you want to insert your SIM card, how you insert your SIM card? How you know that you can insert your SIM card blindly? If you take up your SIM card, you don't let your SIM card look like that with the corner here. So when you put inside the SIM card, some phone, there is a symbol on the insert slot there. They will put this symbol for you. Then you see an arrow pointing here. Okay. Even ATM card, ATM machine, you chuchok, right? You chuchok, do it every month, right? When you chuchok your ATM machine, they will tell you where is the chip side to insert inside the ATM, where to go in first. Right? So this is Pokayoki, means go or no go. If you insert the wrong one, it will reject. You will like straight away, you will prompt out, card cannot use, please reinsert. This one. Okay. Other example like what else? Pokayoki, like they actually a lot in our daily life. Huh? Inside what? Battery. Battery also. You got positive, negative, right? You will see the spring side and no spring side. Okay. Battery also got some shape when you try to insert it, right? So battery also have a side one. If you buy a battery, for your RC car or drone, there's a certain shape of the battery that you can only slot inside a certain way. It's called pokayoki. So again, if you go to work, try to understand what is pokayoki. This will be popular word in the engineering factory or R&D department. They assume you already know what is pokayoki. If you don't know this one, you will be panic. What is my boss talking about? Why always ask me to look at pokayoki? Or pokayoki in Japanese words means stupid, dumb, stupid, proof stupid. I mean, we call you prevent become stupid. Pokayoki means stupid, stupid design that you prevent someone to become stupid. Right? Means you look at it, you already know like how to do already. What else? What is a bad example of not a pokayoki? You know, sometimes on the door, you put a word there, pull or push. That one is very bad. Very bad. Sometimes I'll confuse also. But I have to stop there, think whether I want to, what is pull and push? Right? Yeah, nowadays, like pokayoki, now the seaport, seaport also one of the latest pokayoki design. Like anyhow you chuchuk also will kena the correct way of connecting things. Previously there are lots of USB port. There's a certain shape. The micro SD, the old one, micro SD, there's a certain shape of the micro SD, like that one. Okay, there's a certain shape. So this one also pokayoki design. When you pump petrol also, there's a certain way of pump that one. If you buy an electric car, EV car, there's also a certain way of plugging the charging port. Okay, there are lots of things. Your laptop power source also, hypothesis and all this. Okay, then controller. Okay. Okay, the rest you read. Okay, all these are definition of the wording. This one also you read. Okay. Now, when you go to industry, you will heard about the word Lean Six Sigma. Lean Six Sigma is different from Six Sigma. Lean Six Sigma is a combination of Lean plus Six Sigma. What is Lean? Lean is reduce waste. You reduce waste in your process. What I mean by Lean? For example, in the process, you want to cut a spherical metal sheet. In your process, you are buying rectangular things. So you want to make sure that every time you cut to the very, you use up most of the area. It's called lean, for example. Means you reduce waste in your process. Okay. So then Six Sigma is the one that we've seen just now. You use statistics tools and then you measure it, make sure it's within the range of the Six Sigma. Okay. Okay. So then QFD, quality function development, which is the one that you see on the here, house of quality. You learned the house of quality before. Cause and effect matrix, which is a fishbone, something like that. Right. FMEA, this one you learn in your FEA module, finite element analysis, right? Or in all the software, if you run software for mechanical analysis, then this one is part of the philosophy behind FMEA. T-test is a test, statistic measure. T-test, how many tests you want to do, single T, 2T, 3T, and so on. Okay. Statistic process control, SPC, we will focus on this one in this chapter. We'll teach you how to do statistic control chart or how to read it. DOE, design experiment is a very dedicated chapter. We won't look into this one in detail, but there is one of the quality tools used for your project. Okay, now we start to look at this one. And before you go back today, at least you know how to solve the question using statistic process control. So there are few important component in the statistics process control. Y-axis is your variable, x-axis is your time. So statistic is we look at the time versus variable, and then you plot the graph, and then you see there's a certain trend of it, either it's move up or move down, or stay within the control limit. What is the upper limit? What is the lower limit? There is an equation to calculate upper limit. There's an equation to calculate lower limit. Okay, so equation to calculate average, then you calculate the limit here, the sigma. Actually, you look this one as a Six Sigma graph. You just inverted the Six Sigma graph. Okay, so this is your target. This is Six Sigma to the left, Six Sigma to the right. Okay, this one you read. I will go into how to do this one. This one you do. This one you read. Okay. The word attributes is the characteristics, whether good or bad. Attributes is the product characteristic, color, surface, cleanness, smell, taste, and so on. Variables is all the parameters. Okay. Variables measure, for example, McDonald's, what is the time from the time you order until you deliver? What is the time? Okay, so we start to look at the control chart. So if you look at this graph, control chart, again, a few important parameter, mean, which is the dashed line, mean, average line, upper limit, lower limit. So in this case, you see there is a 1 point on the top here. This is called out of control. Every time that is outside the limit, control limit is out of control. Okay, it's like playing badminton or tennis. There is a boundary there. You cannot go outside the boundaries. Okay, now all the statistics tools, they have two purposes. One is to know where do we want to control it or how tight you want to control it. Another one is monitor the process, whether consistent or not consistent. Okay. Okay. So they are two categories, P chart and C chart. Okay, P chart and C chart. We'll look at this one. Okay, so in general, you know that in statistics, we have 68%, 95%, and 99%. What mean by 68%? 68% is at 1 sigma. You have left-hand side 1 sigma, right-hand side 1 sigma. If you have only 1 sigma control, you are actually controlling 68% of your process. If you have 2 sigma, left and right, you are controlling 95.44% of your process. But if you extend until 3 sigma to the left, 3 sigma to the right, you are actually controlling 6 sigma of your, you're actually controlling 99.72% of your process. Okay. So this one is just an elaboration. Okay. So this is another summary for the statistics graph. 3 sigma to the left, 3 sigma to the right. It means you are controlling 99.74% of your process. The rest you read. Okay, these are the criteria, a checkpoint, whether the process is in control or not. So how you know it is in control? First, there's no sample point outside the control limit. For example, the one on the top here, there's 1 point outside. So if the process is in control, means all the point is within the blue color line here. Second one, most point are near to the process. Most point are near to the process average, means near to the mean point. If can, you adjust your process so that it near to the mean point here. Okay. Then approximately equal numbers of sample point occur above and below center line, means equal number of points. This is a mean point. So 1, 2, 3, 4. 1, 2, 3, 4, for example. So you have equal number of above and below. Right? So means this one is in control. Of course, you have a upper limit and lower limit here. Okay. Then points appear to be random distribute around the center. No disturbable pattern means is within the mean line there. Okay, these are 4 check. Okay, so they are different between P chart and C chart. What I mean by P? P is a proportional defective. Proportional defective is a percentage, right? Then C chart. C chart is number of defects. C chart means you count one by one, 1, 2, 3, 4. But P chart is proportional, means relative number. What is the percentage here? So I give you 2 examples here. The x-axis still the sample number. Okay, x-axis still the same number. So we look at this example. So again, for control chart, they are important axis. Mean, you need to calculate the mean. You need to calculate the upper limit, lower limit. What is different is the y-axis for P chart and C chart. Okay, so we go through a few examples. Okay, so this one you read. So P chart used for defective, non-defective items, state number of defective and percentage as a whole. P chart you can understand it as a percentage of defect, like 1 out of 100 is 1%, right? And so on. Okay, the rest you read. Okay, equation here for P chart. Equation ULC is P plus Z sigma. Lower limit is minus Z sigma. Okay. Oops. What is sigma? Sigma actually is a very standard variation that you learned previously. Square root of P average 1 minus P average divided by n, number of sample. So these are the 3 equations that is important for control chart. Okay, so let's say example 1, a company want to do, you look at the question you know already. 99.74 is 3 sigma left, 3 sigma right. So if you look at the question, 99.7 something, your Z is 3. If you look at, you have 65, 65 means 1. And another one, I forget already, 65, then something, then 99. Or 95% is 2. Yeah, so you look at the question will give you a percentage number. You have percent, you only have 1, 2, 3 only. So you look at the number, 99 is 3, your Z is 3, 95 is 2, 60 something is 1. Okay, so So when you look at this one, of course, we will remove this one. In the test, we won't give you the number of jack. We assume we already know what is jack by the percentage. Random, so control limit where 0.26 of the process variable non-random. So if you take 99.74 plus 0.26 is 100%. Okay, now what does it mean? This is a control chart. Here to here, 3 sigma negative, positive 3 sigma. Here is 99.76%, 74%. Here plus here is 0.26%. Okay. So it takes 20 sample, 1 day for 20 days. Okay. 20 sample. So it means it take 1 sample for 20 days. Each containing 100 pairs of genes. So each 20 sample, each containing 100 pairs of gene, your n equal to 100. So you can calculate the sigma equal to square root p average 1 minus p dash divided by n square. Inspection them for defect, the result shown in the table. Proportional defective is unknown, so the question actually asks you to plot p graph, proportional graph. So the company want to construct a p graph, determine the process whether it's out of control or not. So there are 4 criteria just now to check whether it's in control or out of control. So you just you refer to this table, sample of defective and proportional defective. Again, in the test, you won't see this column. In the test, you only see this one and this one. You need to build proportional defective. How you get, of course, go for 3 decimal place to be safe. How you get 10, how you get 0.1, you add all the numbers, you get 200. So let me see. 200. Oh, okay. Sorry. This one is 200, but this one is proportionally defective because you take 100. You take 100 over per sample just now. Just now in the question, each time you take sample, you have 100 pairs. So for first sample, you find 6 defect. Means out of 100 genes, 6 genes was defect. So you change this 6 into proportional defective 0.06. Don't confuse with the 220 sample here. Okay. Total sample for 20 days. This is a 200 defect out of 20 days. Right. Okay. So P is unknown. You find the average P because you need to find the sigma. Sigma is square root of P, average P, bracket 1 minus bracket P divided by N. So you use this formula, total defect divided by total sample of observation. So it's 200 defect. You calculate out of 20 days or 20 sample, you find 200. And total sample of observation is 20 multiplied by 100 genes. You have 2000. So your P dash is 0.1. Okay, now once you have this one, you write your answer P dash equal to 0.1. Then you control limit compute as following. You know that upper is positive Z sigma, lower limit is Z sigma. Again, in exam or test, you won't see Z value, you'll see how many percent of the variable. Okay, 99 is 3, 95 is 2, 60 something will be 1. Okay. So you put in there. So P just now is 0.1, bracket 1 minus 0.1 divided by 100. you get sigma equal to 0.03. So you substitute this value here, substitute this value here. So you plot the graph. Okay, how you plot the graph is the normal one. Okay. So you have three value, P, ULC, sigma is what? Then you construct the P chart. You construct the P chart. Y-axis is the proportional. You find this one. This one is per how many sample each time? It's 100 genes each time. Okay. Then you plot, like for example, how you find the first point. Number of sample number one. Number sample one is 0.6. So you plot 1, 0.6. 2 is 0, 3 something, 4 something, you plot. Okay, after you plot, then you put inside where is your ULC, what is the LCL, upper and lower. This one important. You write in your graph UCL, how many, LCL, how many, what is your mean, you calculate. These three axes is important, or three lines is important. Then your x-axis, y-axis. This each one might give you 1 point. So only the axis, the line itself, will cost you 5 marks. 1, 2, 3 axis, 2 axis, 5 marks. Okay, and then the calculation. Okay, so 1 mark for line and calculation, 1 line for calculation, and so on. So once you plot, you will see a trend. You will see a trend, then you need to explain the process. Okay, first you look at how you answer this kind of question. First, you answer how many points out of control. After you calculate, you deviate the graph. First, you look at how many points out of control. In this graph, 2 points out of control. You write 2 points out of control. At what? At sample number 2 and sample number 18 or 19. Okay. Then the next one. Okay. So it means that in general, it's a good result, but 2 points are out. Right. So something is wrong in the engineering process. Something must be wrong, or right. So you want, if there is no problem, management will want to know what caused the quality process to improve. Maybe in that day, operator not in good mood. All right. Just throw something inside the process and it out. The process is out. All right. Okay. So this point and this point need to be investigated and so on. And then you will see that actually the whole graph, what is the trend? First question, you answer how many points out of control. Then number 2, you answer what is the trend? Either go up, go down, diagonal go up, diagonal go down. This one is diagonal go up. You can see, right? Diagonal go up. So you can actually make prediction. Actually, the graph will try to shift upwards. If you measure more than 20 days, you will see points will be out of control already. The whole graph will shift outside. I mean, the point was moving on the upper limit there already. So something must be done. Okay. So the process constantly move up towards the out of control situation. Move diagonally upward. Use the correct wording in your answer. Whether it's move diagonally down or up. Okay. So the rest you read. Okay. 2 more minutes, then we end today's lecture. C chart, same. Just don't confuse with the P chart. C, you look at the axis is number of defect and not proportional defect. Okay. So C chart is tell you use when it's not possible to compute a proportional defect and the actual number of defect must be used. So if you're not able to find proportional defect, then you use C chart. For example, the paint job for the car, you're not able to find the blemish you can find, but you cannot find the thickness. It's not possible to know the total number of the surface you're not able to find. Like you cannot go and each car you go and find the blemish. So there's a calculation, same for the same like P chart, but now you change the sigma for C chart. Sigma equal to square root of your average of your control C value. Okay. Square root of your mean. You get just square root of your mean. You know square root, you have positive, negative already. Okay. So the concept apply. You do the same. You plot the same chart and then tell whether it's out of control. What is the trend? Either going up, going down. Then when it's go up, then something need to be done. Process need to improve and give some proposal or suggestion how to improve. Okay. You look at the machine, look at the training of the staff, and so on. Okay. So the rest is the same. So this one you read as your homework. You go and read. It's actually the same. It's a hotel case. 240 and you read lah. So again, there are some tricky words here. Go and read. And you given a table something like this. Okay. So C 190 divided by 15 sample. You get this one. And you find a chart. Okay. So here, whether it's in control or out of control, if you see this kind of chart, in control or not? In control, huh? So in control, okay. Okay. This one you read, huh? Okay, mean chart. Mean chart still same. The formula still same like your P chart, but change the average X bar bar. X bar is what? You calculate all the average divided by the number of sample. You find the average or average. Okay. This is a mean chart. Mean chart means you plot average or average. Still the same, sigma and so on. Sigma is given by this formula. Sigma divided by square root of K. This one you read lah. This is your homework. Go and read how to apply the mean chart by applying the formula lah. Okay, find the ULC, find the double mean, then plot the chart. Okay, so you find the mean and then you find whether the process out of control or not. Okay, so you find the mean, then you look at the average mean here. A double mean here, process average is 5.01. You find all this. Then you have a control limit. Okay, you can plot this one, you can plot X bar and mean ULC, LUC, and number of sample. Okay, in this group is subgroup. Then you see whether it's controlled or not. This one also you read. This one you need this table to calculate D1, D2. Let me see. Okay. When you do not know the standard variation, you use this table. So this table, you have D1, D2, For R chart means for range chart. So you look at this example. Okay. You calculate the range by this formula. Okay. How you know you need to use this one? When you see the table with the R value, you just substitute this value and calculate. Okay, same, find ULC, our limit, upper limit. This one your homework. Go and read how to find. Example 4, your homework, go and find how to do it. Then you plot the graph. You'll see something like this. Okay, so again, observation, this is in control. But again, the graph is moving upward. The defect is moving upward. So you need to make adjustment to your tools. Okay, I think we stop here. Stop here.